Okay, we are coming to page 8, question 5, the last question for this particular package on equation of a circle. You are told that the line cuts the circle at 2 points A and B. We are supposed to find the coordinates of A and B. As like all other questions, please do a simple sketch to visualize the question better. I'm going to draw my circle. I'm going to draw a line. Notice the line actually cuts A and B at 2 points. Let me note that down. In order for us to find the coordinates of A and B, it is very obvious that we need to solve for simultaneous equation to find the intersection of the 2 points A and B. So let us get started. I'm going to label my equation out again before I start solving. So I'm going to substitute equation 1 into equation 2. And do the necessary expansion. Simplify the equation. Notice that this is a quadratic equation in terms of x, and we are able to factorize and solve it. Before we find the corresponding value of y as well. Once that is done, please remember to write out the coordinates of your A as well as your B. Okay, let us move to part 2. We are supposed to find the equation of the perpendicular bisector of AB and shows that it actually passes through the center of the circle. There are two things that needs to be found. First, you need to ensure that the equation of the perpendicular bisector is found first. Using that, you must show that it passes through the center of the circle. Okay, so since the center of the circle is easy to be found, let me do that first. Okay, let me find the center of the circle. Remember, this is the circle that you have. Notice, the x and y terms are missing, meaning the coefficient of x and the coefficient of y are 0. This means to say, the center is equal to 0, 0, which is the origin. Now, let us find the equation of the perpendicular bisector. Please take note, if you need to find the perpendicular bisector, I will need to find the midpoint. And I will need to find the equation of I will need to find the gradient of AB before I find the gradient of the perpendicular bisector of AB. So in that order, I'm going to do that now. Now I'm going to find the midpoint of AB. Using the midpoint formula. After that, I'm supposed to find the gradient of AB. And using that, we can find the gradient of the perpendicular bisector of AB, which is the negative reciprocal of AB. Okay, I'm going to write it in the form of an equation of a straight line, and using the midpoint that I've just found just now, I'm going to find the value of C. So after evaluating it, you realize that the value of C is equal to 0. What does this mean? It means that y is equal to minus half x, which is the equation of the perpendicular bisector of AB, passes through the origin. And the origin is also the center of the circle. And we have proven part 2. Now we are coming to the last part, which is part 3. Going back to the diagram again, you are told that in part 3, this perpendicular bisector actually cuts the circle at P and Q. And we are supposed to find the x-coordinate and show that it can be expressed in that form where k is the value to be found. Similar to part 1, using the equation of the perpendicular bisector that I've just found, I will substitute it inside the equation of the circle. Using a concept of surds, you will be able to determine that k is equal to 2. So now, please try all the following questions yourself.